In this video, we will derive the current through inductor in a driven RL circuit with DC source. It means there will be a voltage source which is a DC Vs, and in this circuit, series RL circuit, the switch S is closed at t equals to 0. In this circuit, at t equals to 0 and greater than 0, the Vs is applied. So we can represent this circuit as simple RL circuit, but we multiply that Vs with ut. What is u of t? U of t is nothing but the unit step function, which is defined as its value is 1 for t greater than equal to 0 and its value is 0 for any other t less than 0. Okay, so when we multiplied Vs source with the ut, it means this circuit, the Vs is applied to this circuit for t greater than equal to 0, which we were representing by t equals to 0. Okay, so this. Now we will apply KVL here to find the equation. Let us apply the KVL. Before applying the KVL, let us define the initial condition, that is at t equals to 0, I of 0 is equals to I0. So initially this is the value. Now apply the KVL. So as KVL say, we will start from here, from VSUT, and we will come back here, and if we are in our direction, right, if there is a polarity from minus to plus, it is positive. If the polarity is plus to minus, it is negative. So it will come, voltage drop across resistance will be negative, voltage drop across inductor also negative, and the voltage drop across inductor is given by di by dt. For whole derivation, we will consider I of t as I for simplicity. Okay. Now we can define that for t greater than 0, u of t is 1. We can rewrite the equation here. Vs minus IR minus L di by dt equals to 0. Okay, and the condition is that t greater than 0. Now rearrange the terms. L di by dt plus IR equals to Vs. Divide the complete or L di by dt, Vs minus IR. Divide complete equation by L, we will get di by dt equals to Vs minus IR upon L. Okay, to proceed further, we have to separate the variables. So I on the left hand side and t on the right hand side. So it will be 1 upon Vs minus IR dot di equals to 1 by L dt. Now what we have to do? Integrate both the sides. Okay. So on the left hand side, we will integrate with respect to I. And on the left hand side, we will integrate with respect to t. And here we will get ln log of Vs minus IR, and it will be divided by minus R. If you remember the integration, yes, Vs minus IR, it will be differentiate, and then it will be whatever the value of differentiation of Vs minus IR, that will be kept into the denominator. So that we will get r minus r. Okay, equals to 1 by L and t plus k. What is k? K is the constant of integration. To find k, no, before finding the k, we will rearrange this term and we will write ln Vs minus IR equals to r on the right hand side minus r by L t minus r into k. Now this minus rk is also a constant, so we can write it another constant as a k dash, and then we will find the value of k dash. Okay, so ln Vs minus IR equals to minus r by L t plus k dash, and now we will find the value of k dash at t equals to 0. So at t equals to 0, I of 0, that is here we have represented by I, is I0 that we have defined initially. So what we will get? Ln Vs minus I0R equals to minus r by L into t is 0 plus k dash, and from here the value of k dash is log of Vs minus I naught r. So what we have to do? This we have to put in this equation 1. So put in equation 1. Equation 1 will become ln Vs minus IR minus r by L t plus ln log of Vs minus I naught r. So again take log terms on one side, equals to minus r by L t. It will become, because in logarithmic algebra, if two logs are in subtraction, then we can write them into the division form. Vs minus IR divided by Vs minus I naught r minus r by L t. Now by taking the antilog of both the sides, what we will get? Vs minus IR upon Vs minus I naught r equals to e to the power minus r by L t, which we can write e to the power minus t upon L by r. Okay, so here that is for t greater than 0. Remember this condition. Now we have to solve it for I, and this, let L by R is the tau, which is a time constant of RL circuit. Okay, so here Vs minus IR equals to Vs minus I naught r multiplied by e to the power minus r by L t, and then minus Vs plus Vs minus I naught r e to the power minus, we can write it in the terms of tau, t by tau. Solve it for IR, solve it for I equals to minus r we will take here, so it will become Vs by r plus minus Vs minus I0R in bracket divided by r e to the power minus t by tau. So the final equation we can write as Vs upon r, minus sign we can take in, and we can write that I naught r minus Vs divided by r e to the power minus t by tau. This equation is for t greater than 0. So this is the equation of driven RLC circuit, where the circuit is driven by a DC source. It is also called as step response of RL circuit.